So let's start off by reviewing the rules. We're gonna start with the differentiation rules. The focus is just on polynomials, okay? So the first one, we had the derivative of a constant, so d dx of a constant, let's say a, is equal to 0. What this basically means is, what's the slope of a constant line? A constant line is horizontal, so what's the slope? What's the rise over run? The rate of change of a constant function is 0 because the rate doesn't change over time. It stays the same. Okay? And then we looked at the derivative of a constant and a variable known as a constant multiple. So if you have ax, this is similar to y equals mx plus b. The slope is represented by the coefficient. So when you differentiate this, your rate of change is a coefficient, which is simply a. Number 3, we have the famous one, the power rule, derivative of x to the n. So for this one, you power down the exponent and you mark it down by 1. So if you want to calculate the rate of change of any polynomial term, this is the formula that gives you the function that represents the rate of change. And then lastly, we have a combination of multiple and power rules. So if you want to find the rate of change or slope of the tangent line of ax to the n, what you do is you factor out the a. Okay, so factor out the a, and then I introduced a notation yesterday, the prime notation, which is another way of writing the derivative. Okay, and then you apply the power rule here, and then your answer is going to be ax. No, let me correct that. A, you power down the n, x to the n minus 1. So it's just like this one multiplied by the a. Okay? And then we also looked at the integration rules for polynomials. Started off by taking a look at what is a integral of nothing, of 0. So if you integrate 0 with respect to x, you're going to end up with a constant. Remember, integral is the reversal of differentiation. If you're integrating 0, ask yourself, what do you differentiate? Hint, hint. What do you differentiate to get 0? Okay? You differentiate a constant to get 0, so the integral of 0 is a constant. It represents any number. Number 2. What's the integral of a constant? You ask yourself, what do I differentiate to get a constant? Look here, ax. If you differentiate ax, you get a constant. So if you integrate a constant, you get that constant multiplied by x. And you add c, because everything is plus 0, right? And then when you integrate 0, what do you get? C. Number 3, we also have the power rule for integrals, integral of x to the n dx. When you integrate that, you have x to the power plus 1 divided by power plus 1 plus the integral of 0, which is c. And then lastly, we have the multiple rule. So if you integrate a x to the n dx, the same approach here, you can factor out coefficients from integrands. So you can factor out the a, and you're integrating x to the n dx. And your final result is going to be ax to the power plus 1 divided by power plus 1 plus c. Okay, so these are the rules that we reviewed yesterday. Now, there's another rule I'm going to introduce, which is the integral of 1 over x dx. The power rule does not work here. The integral of this is a natural logarithm of the absolute value of x plus c. Now let's take a look at the following example. Number 1, example. For y equals 2x to the third plus 5x squared plus the square root of x to the third. Let me write that properly. Square root of x to the third plus 1 over x. I want you to find three things. You're going to find number one, find the derivative, dy dx. Number two, find the integral. And then number three, find the limit as x approaches 1 of the function. With the first one, number one, I want to find dy dx. dy dx is the same thing as y prime. Okay? So if you have y is equal to 2x to the third plus 5x squared plus the square root of x to the third plus 1 over x. I want to try and see, can I write everything as a power? Okay? So that's what we're going to, that's the approach we're going to use here. So rewrite as powers. Rewrite as powers if possible. Okay, if I rewrite everything as powers, I'm going to have y equals, this is already a power, right? 2x to the third plus 5x squared. So let's rewrite them as powers. You have plus x to the 3 halves. There's an invisible 2 here. There's a 1 down here. So when you reciprocate, you negate the exponent, x to the negative 1. So we're differentiating a polynomial, which is a sum of powers. So y dy dx, which is the same thing as y prime. We're going to do its term by term differentiation. Okay, so 2x to the third prime plus 5x squared prime plus x to the 3 halves prime plus x to the negative 1 prime. Okay, we have 4 powers. The formula for differentiating powers, we just went over it. X to the n, the main formula, x to the n prime is power down, power, I mark the power down by 1. Okay? And if you have a coefficient, you factor it out. So let's apply that here. Let's factor out first. So we have y prime is equal to factor out the 2, x to the third prime, factor out the 5, x squared prime. There's nothing to factor out here, so let's leave it alone for now. And then that one, let's leave it alone for a second. Okay, we are now ready to start differentiating one at a time. So let's look at the first one. Y prime is equal to, alright, so it's going to be 2 power down to 3, x to the power, mark it down by 1, plus 5 power down to 2, x to the, mark down the power by 1, 3 over 2, x to the 3 over 2, mark the power down by 1, but an equivalent fraction of 1 is 2 over 2, so I can subtract it without wasting time. And then this, I'll power down the negative 1, so it changes this plus to a minus 1, x to the minus 1, mark it down by 1. Now to simplify, we want to make this look pretty. We're going to have y prime equals 6x squared plus 10x plus 3 over 2 x to the 1 half minus x raised to the negative 2. Now let's make it look pretty. We're going to have y prime equals 6x squared plus 10x plus 3 over 2. If you write x to the 1/2 as a fraction, is root x. And then minus, if you reciprocate that, using the reciprocal property, negative x to the, 1 over x square. So that, ladies and gentlemen, is a derivative. What this basically does is it helps you calculate the slope of the original function at any x value. So give me the x value, and this function will tell me what the slope is, the slope of the tangent line at that point. Okay? Alright, so for part 2, we want to find the indefinite integral of y dx. So the integral of y dx is basically the integral of this entire expression, 2x to the third. Let's write it as powers to save time, okay? So 2x to the third plus 5x squared plus x to the 3 over 2 plus 1/2, 1 over, no, we changed, let's do this as 1 over x. 1 over x is not written as a power. There's a special reason why. The reason is that the power rule cannot be applied to 1 over x when you're integrating. That's a common mistake most students make, is they try to apply the power rule to 1 over x when integrating, and you cannot. Okay? So, the two rules that we're going to be using to guide our integration process, let me put it here, formulas, are 1, the power rule. The integral of x to the n dx is x to the n plus 1 over n plus 1 plus the integral of 0, which is c, and the integral of 1 over x. You do not use the power rule for this. This has a special integral, which is a natural logarithm of x plus c. Okay? Now, let's go ahead and do it. Just as we did for the inner derivative, we're going to integrate them one by one, term by term integration, since they're separated by pluses. So we're going to have the integral of 2x to the third dx plus the integral of 5x squared dx plus the integral of x to the 3 over 2 dx plus the integral of 1 over x dx. Okay? So we're going to do term by term integration. We're going to use the power rule for the first three, and then on the last one we're going to use 1 over x. Alright, so we're going to go ahead and factor out coefficients if possible. So this has a 2, so we can factor that out. Integrate. We're going to be integrating x to the 30x. We can factor out the 5 here, x squared dx, and then we can, there's nothing to be factored out here, let's leave it alone. And this one, there's nothing to be factored out, let's leave that alone. Alright, we're ready to start applying these two rules that we mentioned over here. So let's apply the power rule. We have 2. Integral of x to the third is x to the power plus 1 divided by power plus 1 plus 5 x to the power plus 1 divided by power plus 1 plus x to the power plus 1. I'm going to write 1 as 2 over 2. That's the equivalent fraction, divided by power plus 1 plus the integral of 1 over x is a natural logarithm of absolute value of x plus the integral of 0, which is a constant c. Alright, let's go ahead and simplify this. We'll have 2x to the 4th over 4 plus 5x to the 3rd over 3 plus x to the, if you add that up, you have 5 over 2 over 5 over 2 plus the natural logarithm of the absolute value of x plus c. Let's simplify, and that will be our final answer. you could divide here. 2 goes here 1, 2 goes here 2. So you have x to the fourth over 2 plus 5 5 third x to the third power plus, now you can drop change flip, so you multiply this by the reciprocal of 5 over 2, which is 2 over 5 x to the 5 over 2 plus the natural logarithm of the absolute value of x plus your constant c. That is the integral of y dx. Okay, so let's go ahead and box that. Alright, so the last part is to evaluate the limit. Number 3. Evaluate the limit as x approaches 1 of your function. So what this is saying is, what is the output when the input gets really close to 1? You don't have to get to 1. The output does not have to be defined, but you're getting really close to the output you're approaching. Okay? So let's go ahead and take a look at it. So what's the limit as x approaches 1 of the function, which is 2x to the third plus 5x squared plus the square root of x to the third plus 1 over x. So what is the intended output value? It could be defined or not. I don't care what the output value is, but if it's defined or not, what I care about is what is this function approaching? What is it getting really close to? Okay? Alright, so let's go ahead and do it. So what you're going to do is you're just going to substitute first and see what happens. That's the first step in finding limits. Substitute. If you get an answer, you rejoice. If you don't, then there are other procedures you can implement. Alright, sometimes the limit does not even exist. You're not approaching any specific value. Alright, so let's go ahead and do that. So for this, you're just going to evaluate. You have 2 times 1 to the third plus 5 times 1 square plus the square root of 1 to the third plus 1 over 1. Just substitute and see what happens. Okay? If you simplify using your order of operations, you have 2 plus 5 plus 1 plus 1. 2 plus 5 is 7. 7 plus 2 is 9. Okay? So what does this mean? Meaning is as x gets close to 1, really close, infinitely close, y approaches the value of 9. That's what this answer means. Okay?